Welcome back. Today we're going to be talking about monomers and polymers. Polymers are very large molecules. Sometimes people call them macromolecules. And there are four major macromolecules that are essential to life. And you've probably heard about them before if you've ever looked at a nutrition label. We have proteins, carbohydrates, lipids, and nucleic acids. So let's break this down. Macromolecules are polymers. So let's look at the difference between monomers and polymers. Mono means one, single. Poly means more than one. So a monomer is a simple structure, one simple thing. And a polymer is much more complex. It's made up of hooking together a bunch of monomers of the same type and forming a much larger structure, a macromolecule. So how does this work? So imagine you have this box. That's a monomer. And you can hook it together with another box. So now you have two monomers. And then you can add a bunch more monomers. And now you're starting to have a much more complex shape. And then a bunch more of the same monomer. And you see how they're all the same and they're all kind of hooked together, or at least arranged together. And that's what we would call a polymer, or a macromolecule. You can see that we have a complex set of monomers that are put together that kind of looks like maybe a brick wall. How would you hold a brick wall together? Well, you would put mortar or cement in between. In the body, we don't want to use something that's that permanent. We don't like to commit that long. Sometimes we want to build things up, and sometimes we want to break them down and use them for other things. So we have to put our monomers together and hold them together with something that's strong, but not something that's like permanent for 100 years, right? So what we're going to do is we're going to use covalent bonds to hold our monomers together. How would we do that? First of all, you're going to take your first subunit, given a little bit more detail so you can see that we have these hydroxide ions hanging off. If you take a second monomer, it also has the hydroxide ions kind of hanging off of it. And what we're going to do is we're going to take an enzyme. Enzymes are really important for making reactions happen. And we're going to take those two hydroxide ions that are close to one another, and we're going to remove them. And we're going to take away water. So we know water is H2O, so we're going to take away the two H's and one of the O's from these two monomers. And the water goes off. But what happens to those atoms that we just took away the H's and the O? They were very happy. They had fulfilled their octet rule. They were very happy sharing electrons with the other atoms, and now we just basically ripped away those atoms. And so there's a void. They are no longer fulfilled. So what we're going to do is we're going to form a covalent bond between these two monomers so that all the atoms involved are happy and they fulfill their octet rule. And there's our covalent bond. So that oxygen that was left behind is going to hook together monomer 1 with monomer 2. And this is a specific kind of reaction called a dehydration synthesis. The reason it's called dehydration is because we're actually taking water away from the environment. So the enzyme is holding these two guys together and ripping off some water and forcing them to make a covalent bond so that they can satisfy their octet rule. You can see that up here in the top of the graphic. We're taking away the OH from one subunit and the H from the other subunit, removing water and causing a dehydration reaction which forms this covalent bond. Now we can do the opposite. We can take two subunits that are bound together, we can actually rip them apart. You see that down here. Here's these two. They are held together by a covalent bond. We're going to add in, we're going to rip them apart, we're going to add in that water, and you're going to end up with two individual subunits. So dehydration synthesis, you can think of as dehydration in that we're taking water away from the reaction. And when we take away the water, we're leaving these two sort of naked subunits that want to bind together to fill in for the missing water. And so dehydration means you're taking away water. Hydrolysis, however, hydro means water and lysis means breaking, means that you're taking water and you're actually adding it back into the situation. So we're breaking apart a large molecule and putting water in there to sort of fill in for where the atoms got ripped apart. So dehydration synthesis is what we use when we're growing, for growth. Whereas hydrolysis is what we use when we want to break things down, such as in the process of digestion. That's it for today. Come back for the next video, which is on macromolecules. See you in class.